A rocket is supported by 3 cables. Cable AB has a force of 150 newtons. Determine the upward force of the rocket. So first off, to start off, we want to list what we know. So we know that the force AB in the x equals force AC in the x. And that is because force AD doesn't have an x component. Next up, we know that the force AC in the z equals force AD in the z. That's because force AB doesn't have a z component. Next up, force AB in the y plus force AC in the y plus force AD in the y equals the force of the rocket up. Next up, we want to start off by making all of our unit vectors. So first off, we'll start with AB. We want to write our rectangular coordinates of length. So we know it's negative 15 meters I because it's going to the left, and it's minus 8 meters J because the rocket is going up, so these cables will be going down. And then it's plus 0 meters K because it doesn't have a Z direction. To find the total length, we want to add all of them up and square each unit, and that gives us 17 meters. To find the unit vector, we simply just divide each unit by 17. So that gives us the unit vector of 1 equals negative 0.88 I minus 0.47 J. There's still no unit for K because it's not in the Z direction. Since we know that the component of force is 150 newtons, we can find the entire force component. So 150 equals, and now to find that, you simply multiply 150 times 0.88, negative 0.88, so that gives you negative 132 newtons I minus 70.5 newtons J. So AB is completed. Next up, we can move to AC. AC, we want to write the components of length, and that equals 3 meters in the I direction, right here, minus 8 meters J, because the rocket is pushing up and the cables are pulling down, and then plus 10 meters K, because it now has a Z direction. To find the full length, we get 13.5 meters. Now we just divide each unit by 13.5 to get the unit vector. So 1 equals 0.23 in the I direction minus 0.61 in the J direction plus 0.76 in the K direction. Now AC is completed and they're all positive except the Y because these are both in the positive direction. Lastly, we could do AD. AD equals, it does not have a X component, so it's simply 0 meters I, and it's the same Y value, so it's minus 8 meters J, and then it's going to be minus 12 meters K, because it has a negative Z value. Now this all equals 14.42 meters. Now we can find our unit vector. So 1 equals, it's going to be negative 0.55 J. So negative 8 divided by 14.42 equals negative 0.55 J. And then minus 0.83 K. The 12 that was divided by the 14.42. So those are all our unit vectors, and we have our force vector for the 150 newtons.
So in order to find all the Y values for to get the upward force of the rocket, we were going to use our comparisons or our equations that we made up here. So force AB in the X direction is equal to force AC in the X direction. So we know force AB in the X direction, which is 132 newtons. So we take 132 newtons equals, we do not know force AC in the X direction. However, we could say force AC times its unit vector, which is 0.23 And then we can find and solve for force AC. So we're going to divide by 0.23, so force AC equals 573.913 newtons. So after finding force AC, we can multiply it times all the components in the unit vector here and find the equation. So it's going to be 132 newtons in the I direction minus 350.08 because 173.913 times 0.61 in the J direction equals 350.08 in the J direction. Oh, newtons in the J direction, my bad. Then plus, so 573.913 newtons times 0.7 in the K direction equals 436.174 in the K direction. And it equals the force, the total force, which is 573.913 newtons.
All right, to find the force of rope AD, we're going to have to take the unit vector equation of 0.55 and 0.83, and because force AC of Z and force AD of Z are equal, we're going to be able to take the final force of AC of Z and use that to find this. So 436.174 is equivalent to 0.83 AD, and once you divide those out, you're going to get 525.51 newtons, which is the total force of AD. And we're going to multiply these actually by the unit vector equation. And x is equal to 0 because there is no force there. The y is going to be 289.03, and it's going to be a negative because that's the direction. And z is going to be 436.174. And that's how you find the next y component. And then the final step to this equation, we're going to have to take and add up all the y components. So it's going to be negative 70.5 plus negative 350.08 plus negative 289.031, and these are going to come out to a total of negative 709.61 newtons, and the negative is because of the direction, and that is the total upward force of the rocket.